Hey guys, welcome back to a new video. So as promised, in this video we will test our shopping view model. So you will learn how to do that. Let's make sure that you are inside of your shopping view model class, right click on the class name, click on generate, and then we click on test. So Android Studio will generate that test class for us. We won't select Groovy JUnit here, we will instead use JUnit4. The class name is fine and we just press OK. And well, in which source set we actually want to create that test case. We will do that in the test folder because a ViewModel is just a plain class that is not an Android component, and for that we can simply run those test cases on the JVM, which we should always do if we can do that. So we select test here, press OK, and you can see Android Studio generates us that test class. Alright, so what will we actually have in this test class here? Of course, we want to test our actual shopping view model, so what we of course need is an instance of that. So we create a private late init var view model, which is of type shopping view model. And inside of the before function, so the function that is executed before each of our test cases, the setup function, we want to initialize that view model. So view model is equal to new shopping view model. And now you can see we need a shopping repository. And now it also should get clear why we created that fake shopping repository, because in this test class here, we will need that right now, because here we don't want to create a default shopping repository, because for that we need a shopping DAO and a Pixabay API, which we don't want to use in our tests because making API requests or database calls just takes time. And unit tests should run fast, so we definitely don't want that. What we will instead do is we will simply use our fake shopping repository here and instantiate that. You can see that doesn't take that Node DAO and Pixabay API. So if you remember, that fake shopping repository just imitates the behavior of our real repository, but in a way that is very efficient for tests, because that just uses a plain list data structure and not a real database. So that is much more efficient and perfectly suited for our tests here. Then we can write our actual first test case in here. So add test function, and let's actually first test if we want to insert an item into our database and we leave one field empty. So that of course should return an error. And I will use that backtick type of writing again, because we're inside of our test folder and not our Android test folder, where that isn't possible sadly, but here we can use that. So we can just describe what our test case tests and what we expect it to return. So insert shopping item with empty field returns error. So that is our function name, and in here we can write the test case. So first of all, we of course want to use our view model and insert a new shopping item here. So we use our insert shopping item function here, not that shopping item into DB function. We just want to check if the validation of the input is correctly here. So ViewModel.insert shopping item, choose any name. Let's say we'll leave the amount string empty here, because as I said, we want to test if we insert a shopping item with an empty field, we test if that really returns an error here. So we of course also need to provide an item with an empty field. And for the price, we can put anything here, that doesn't really matter. Then we want to get the value of the resource we emit in our view model. So that function actually emits such a resource class, so either loading, success, or error, depending on if that input was valid or not. And we want to get the result of that, so value is equal to ViewModel dot insert shopping item status, that is the live data in which we will post that status later on, dot get or await value. And you might remember that function, we used that before, but right now it doesn't recognize that because we are inside of our test source set, and we created that extension function in our Android test source set, and those are not really compatible with each other. So if we create a class in our Android test source set, then we can't use that in our test source set. So what we have to do is we need to just copy that class over here to the test source set. Let's open our Android test source set here, take our live data util Android test, copy that, and in our test source set we simply paste that, and we move the Android here, so just live data util test. And then also rename this to get or await value test, and also down here. And then we can go back to our shopping view model test and also append a test here. And then we can import that, and we don't get any error. And now we want to assert that this value here, so if we press Ctrl Q on that, you can see that returns an event of type resource of type shopping item. And now we want to assert that this resource here is actually an error resource. So if that is an error resource, this test passes, because if we want to insert a shopping item with an empty field, we expect it to return that error resource. So what we will do is we will write assert that, and we don't want JUnits assert that function. So what we will do is we'll remove this JUnit assert import here, delete this, and re-import this function, pressing Alt plus Enter. And this time we will use that assert that function from the truth library. And then we can simply pass our value dot get content if not handled. So the first time we call this function, this will actually just return the content, so our resource here, and that is the first time we call that here. And we make a null check and use dot status. And then we can simply check if that is equal to status dot error. Okay, that's already it for our first test function. Let's create another one. Make a little space here. And we can actually just copy this test block and just make some adjustments on that. I will call this insert shopping item with too long name. So let's say we enter a name that has more characters than our max name length we created in the last video. So in our constants file, we have that max name length, which we set to 20 characters. And now we want to test if we enter a name with, let's say, 21 characters, if it really returns an error in that case. So we go back to our shopping view model test. And this time we want to insert a shopping item with a valid amount. So the amount, let's say 5, but the name should be of length longer than 20. And because we don't want to hardcode this at 20 here, instead we want to make this dependent on our constant, because if we change the constant, we shouldn't also change the test case. This should always be dependent on basically the constant we choose for the max length. So what I will do here is I will actually create a string with a string builder that is just 1 character longer than our max name length constant is. So val string is equal to build string, which is a cool Kotlin extension, or not extension, cool Kotlin lambda function, in which we can just have an instance of a string builder, and in here we can create a for loop for I in 1 to constants dot max name length plus 1. So we actually just make sure that we add 1 more character as our max name length is. So we can simply use append to append a new character to that string builder, and it doesn't really matter what we choose here. I will just choose a 1, and then we can use that string and pass it for our name. So the advantage of this is that even if we now change that max name length constant, let's say to 30, then this same method will construct a string with 31 characters. So that will still be a valid test case. But if we hardcode this, let's say we would write a string in here with 20 characters, and then we increase the max name length constant, and then this test case will fail, even though it shouldn't fail. And then we also need to change the test case again, which we don't want. So we really want to make sure this is dependent on that constant here. Okay, and then next I want to have a very similar function for our max price length. So we actually have another constant here for our max price length, which is 10 characters. And I also want to test the same here, that if we enter a price that is too long, that it should return an error. So we paste that again, insert shopping item with too long price this time. We also want to construct a string here this time with max price length. And for the name, we just choose name again. And for the price, this time we will use that string. And then what can we test next? We can actually test if we enter an invalid amount. So the actual reason we don't have such a constant here for the amount is because the amount is an integer. And integers behave different than floats, so that price is actually a float. And if we enter too high number for a float, then it will simply display infinity. But for integers, if we overflow that integer basically, then it will crash, I think. So for that, we need to use some other logic. We don't want this string builder here. Instead, that is simpler actually. We just enter a name for the name here. And for the amount, we just enter a very large number where no way that can be saved in a single integer variable. And the name of that function will be insert shopping item with too high amount, and that should also return an error. And let's add one last test case for our insert shopping item function, which is of course the test case that should succeed. So if we enter a valid item, then it should return a success status in the end. So let's copy that again one last time, paste that below. We will choose a valid amount, a valid price, a valid name, and actually also change the function signature here, insert shopping item with valid input, and that should return success, of course. So first we insert that item with valid inputs, then we wait for the status to emit a value, and then we simply want to assert that this value, so the status of that resource, is actually equal to status.success this time. Okay, so if we now actually run our test cases, then we get an error that the command line is too long, shorten command line for shopping ViewModel test, or also other Android JUnit default configuration. Let's click on default here. Then this window will open up, and here we can basically choose something for shorten the command line, in which I will just choose jar manifest here. So that is just an option we need here so that this error goes away. We press on OK. And if we now rerun our test cases, then you can see now that works. Our test cases all fail. That is what we expected because we don't have the implementation yet. But also something important we need to consider here is that the same way as we did it in our Android test where we tested our DAO, our database functions, we also must use that instant task executor rule. So we implement a JUnit rule here with @get:\rule called instant task executor rule and set that to a new instant task executor rule. So that will just make sure that everything will run in the same thread, one action after the other. So if we now rerun our test cases, then wait a moment, and you can see now something works differently. All the test cases basically wait until the live data emit a value, but since they don't, you can see live data value was never set. They just all time out because we don't post anything to the live data yet, since we don't have the function implementation in our actual ViewModel yet. But the error from before is gone because we implemented that instant task executor rule here. So let's actually change that, and according to TDD principles, let's now implement the actual function, because now we have the test cases that test the function and all fail. So now we implement the function in a way that these test cases shouldn't fail. Let's go to our shopping ViewModel and also minimize that and start with our insert shopping item function. First of all, let's make sure that we post an error resource if any of these fields are empty. So if name dot is empty, or amount string dot is empty, or price string dot is empty. If one of these is the case, then we simply want to use _ insert shopping item status dot post value event of type resource dot error. Oops. Control P is what I wanted to do. And the message for that is the fields must not be empty. And for the data, we simply pass null here. And then we can just return out of this function. Okay, so next, if our name dot length, if that is greater than our constants dot max name length, and then we also want to emit an error resource. So underscore insert shopping item status dot post value event of type resource dot error with a message the name of the item must not exceed constants dot max name length characters. And again pass null for the data because we don't have any yet. And also return out of this function. Then next, let's actually copy that, paste it below, and do the same for the price. So if price string dot length is greater than constants dot max price length, and then we want to post an error resource. The name, instead of that, we use the price of the item must not exceed max price length characters, and also return out of this. And what is missing, we also need to worry about the amount. So we just create a val amount, which will be the integer amount, and we set that equal to try amount string dot to integer. And if that fails, so if we catch an exception, E is an exception, but I want the Kotlin exception here, then instead, we will post a new value in underscore insert shopping item status. So that post value event resource dot error with a message, please enter a valid amount and pass null. And don't forget to return here. And now we can actually construct our actual shopping item. So val shopping item is equal to a new shopping item. First of all, the name will be just our name. The amount will be our amount. The price will be our price string dot to float. The image URL will be whatever is in our current image URL dot value. And if that is equal to null, we will simply use an empty string here. And then we can use that item to insert it into our database. Insert shopping item into DB. Pass our shopping item here. And I also want to use set current image URL and reset that basically to an empty URL. Because if we insert a new shopping item into our database, then we will directly pop the backstack. So we navigate to our shopping fragment, so where all the shopping items are displayed. And if we go back to add a new item, then we want to show an empty image basically. So we don't want to show the same image as we did before. So that is why I will clear that current image URL. And by the way, you can take it as a homework to also test this functionality. So if we insert a shopping item with valid input, that you test that this image URL is empty afterwards. So take that as a homework and write the test case at home. And in the end, we just want to use our underscore, not image, underscore insert shopping item status again, and post the value event resource.success this time, because if we reach this point, everything was successful, and we can attach our data, which is our actual shopping item here. So let's actually also implement this search for image function, which will be much lighter than our insert shopping item function. So we check if our image query is empty. In that case, we just want to return out of this function. We don't want to emit an error resource here, because it could be that the user just deleted his search string, so he just erased all characters, and then we don't want to show a snack bar or something like that, because that is not really an error. And then if this is not empty, we want to use our images live data and set the value to a loading resource. So event resource.loading, and we pass null for the data. So if you wonder why I use images.value here and not post value, the difference is that .value, if we just set the value here, then the change will always notify all of our observers of that live data. If we use post value, and if we would use post value several times in a very short time frame, then only the last time will notify our observers. And for our test cases later on, it will be very important that we choose .value here, because we need to make sure that our observers actually always get this loading resource and then get the success resource or the error resource, so that we can just test that properly. So in actual production in a real app, this is not noticeable if we use .value or post value here, but for our test cases that is indeed very important that we also get this loading resource here and not directly the success resource. So that is why I will use that .value here instead of post value. Anyways, afterwards, we want to launch a coroutine because we want to make our API request. So ViewModel scope.launch, and in here we will get the response by writing val response is equal to repository dot search for image, and we pass our image query. And then afterwards, we can simply use our underscore images live data again and set the value of that to event of response, because our response is in the end just a resource and we just want to wrap an event class around that. So now we implemented our view model. Let's go back to our shopping view model test and rerun our tests, and you will see that they will fail again. I will explain why. So let's wait a little moment here. And why? Okay, we have two exception imports here. Let's remove one and run again. So run our test cases again. Wait a little moment until Gradle does its job. And you can see we get an error here. Even though the test case is all passed, we get an exception in thread main. Module with the main dispatcher had failed to initialize. Okay, so the reason why this failed is if we take a look in our shopping view model, you can see we actually use a coroutine instead of this insert shopping item function, because this calls our insert shopping item into DB function, and here you can see that is a suspend call, and that uses the main dispatcher, which we don't have in tests, because the coroutine main dispatcher relies on the main looper, which is only available in a real app scenario, basically. So if we launch a real app, but since we are inside of our test source set here, where we run our tests on the JVM, we don't have that real app environment. So we also don't have access to that main dispatcher. If we would have our tests inside of the Android test directory, then this wouldn't be a problem, because then we test our tests on an actual Android device, but here we don't. So to solve that problem, we need to define our own JUnit rule. And sorry, this video is getting very long, but this is really the last thing we will do in this video to create that rule. So we will go to our test source set here, and inside of that package, we will create a new Kotlin follow class, which will be called main coroutine rule. So we will just use a special dispatcher, which is not the main dispatcher, and then we can just use that rule in all of our projects, in all of our test classes where we need that, where we actually use coroutines inside of the test source set, and that won't be any problem anymore. So let's actually minimize that here. First of all, we annotate that with experimental coroutines API, and in the constructor of that, we can pass the dispatcher for that rule. So private val dispatcher is a coroutine dispatcher, and we set that by default to the so-called test coroutine dispatcher, which is exactly suited for these test cases in the test source set, as I said. And that will inherit from test watcher, which will, so the test watcher implements the test rule interface, I think. And that is what makes this class an actual rule for JUnit tests. But we also want to inherit from test coroutine scope, and we use by test coroutine scope, and we pass our dispatcher here. So inside of this class, we on the one hand want to override the starting function. So when we actually start a coroutine with this dispatcher here, with this rule, actually, if this rule is active and we start a coroutine there, then we want to use dispatchers.setMain. So we can choose a different dispatcher for the main dispatcher. And for that, we will simply use our test dispatcher we pass as a parameter. And if there is a starting function, then there's also a finished function, in which we want to, first of all, clean up test coroutines so that all these finish, and afterwards we call dispatchers.resetMain. So that will just undo what we did here. So when we start a coroutine, we replace the main dispatcher with our test dispatcher, and when that coroutine is done, we will just set the main dispatcher to the real main dispatcher again by calling resetMain. And if we now go to our shopping view model, actually the test function, test class here, and implement that rule, also add get:rule var main coroutine rule, which is a main coroutine rule. And you can see we also get a warning here because we need this annotation, experimental coroutines API. But now we actually have that rule, and that applies to all of our test cases here in this class. So if we now rerun our tests again, then hopefully we shouldn't get an error this time. And as you can see, all tests pass, we don't get an error, everything is working perfectly fine. So if you followed through this video until now, then congratulations. Now you know how to test view models. That is very important. And I also got a little homework for you, which I also mentioned already. In the shopping view model, there is this insert shopping item function. And as I said, you can just test if this really sets the current image URL to an empty string after we successfully inserted an item. And you could also test this setImageURL function here. So just test if you call this function with any URL, that this URL can be observed from this live data afterwards. So take that as a homework and you can practice with that. So please, if you like this video, hit the like button. If you love this video, give me a comment below. And if you are not a subscriber of my channel, then just subscribe to it. You will get regular Android content every second day. Have a really nice day. See you in the next video. Bye bye.